Okay, everybody, we have a request to do Fall 19 Test 4, Part 1. We're going to do the first 5 questions, 3 of them in this segment. And they're all about pKa, everybody. We have to figure out the closest value to KEQ for tier, which is tyrosine, when it has a charge of -1, reacting with histidine when it has a charge of +1, to give tyrosine, which clearly picked up a proton. The only way to go from minus to neutral is to add a proton. So this will have a pKa because it will be the acid on the right side. And histidine went from plus to neutral. That means it lost a proton. Acids are the things that lose protons. So we need 2 pKa. pKa equals 0. What? You know where that came from. It has a 0 charge. pKa is not 0. All right. Where's my eraser? Okay. Getting our stuff together here. We need to know the pKa of histidine when it has a +1 charge. That's our first job. And we need our useful information handout for histidine when it has a +1 charge. If you're looking at histidine right now on this handout, it has a charge of 0. So what you have to do to give it a charge of +1 is to add an extra proton, and it goes right here. So that will be the acid right there, 6.10. The only way to make this thing plus is to put a proton here. Now, if you're saying, hold on, Dr. Whitaker, I know another way to make histidine +1. I'm going to put a proton right there. Yeah. Mission accomplished, but you totally forgot the rules of pKa. You're not living in reality. We must live in reality. This will pick up a proton first. This will not. Why? This is a better base. Why? pKb, 14 minus 6 is 8. pKb here, 14 minus, call it 2, is 12. 8 is a much stronger base than 12. So just to repeat, histidine with a +1 charge has a proton here, which will be the most acidic proton. 6.1 is the number I need. I'm going to copy 6.1 on our starboard. 6.1. Now I need tyrosine when it has a charge of 0, and I need to know what the most acidic proton is on tyrosine with a charge of 0. Here we go. Tyrosine down here. Right now it has a charge of 0. Nice. What's the most acidic proton on this picture? Because it's the one we have to use. It's not the 10.1, it's the 9.1. Don't use the 2.2, there's not a proton there. When the proton's there, it's 2.2. So 9.1 is the only number of interest. And we're going to put that for tyrosine right here. So our answer is 6.1 minus 9.1. That's not quite the answer. Equals -3. KEQ equals 10 to the +3. And the closest answer is 10 to the +4. So yeah, you won't have the exact answers here, ladies and gentlemen. Also a test of your confidence. 10 to the 4 is much closer than 10 to the 1. It's off by a factor of 10, not by a factor of 100. All right, now this one's got some thinking. We need to do some thinking because we want to know, I have to choose the answer that would produce the highest amount of products for question 3. So the one that goes forward the most. I don't know if this is going to be an acid or a base, and I don't know if this is going to be an acid or a base. We have to figure that out. Let's just do a quickie. If this is a base, then it's going to go to, it's going to pick up a proton. It's going to go to H3ASO4. pKa is 2.2. I doubt we're going to go towards the 2.2. I don't know, but I doubt it. It's low. Do we go towards strong acids? Not usually. If I lose H+, it's going to go to HASO4 2 negative, pKa. Now, how do I know that's 11.5? It's the last proton on there, isn't it? Well, there's the first proton, there's the second proton, there's the third proton. Yes, I will give you a new CRC reference for probably a triprotic acid here. You'll find 2 or 3 examples already at Moodle in older exams, I promise. So we're going to that. Now, if we're going this direction, where this thing picks up a proton, well, where's it picking up the proton from? This thing. So I got to find what the most acidic proton is here. Okay. And I just remembered something. Yeah. If this thing loses a proton, then the 11.5 is not relevant. I got carried away. If this thing loses a proton, then that's the acid. Oh, Dr. Whitaker. So this was irrelevant. It's not the acid if this thing loses a proton. This is the acid. And the pKa is 7.9. pKa is 7.9. And if this thing picks up a proton, that would be the red situation. We got to figure out what the pKa is when question mark picks up has the extra proton. Okay, so of these protons available here, I have a 10.1, which I just happened to remember from looking it up recently. The tyrosine ammonium ion is what? Tyrosine ammonium ion is, where are you, tyrosine? 9.1. 9.1. So get rid of the 10.1, irrelevant. There's no H's here or here. Never talk about amide H's for pKa of amino acids. Never talk about them. So I should have put that in blue because that's the blue scenario. That loses a proton to this, which becomes this acid. I don't think 9.1 minus 2.2 is going to be the one going most to the right. 6.9, I think, right? I don't think that's going to be our best equilibrium. I told you this is a sneaky little problem. But it really shows an understanding of pKa to be able to do this problem. All right, so that's the scenario if this thing's the acid. Now, if this thing's the base, where's the best base available? Is it this site or this? And I'm pretty sure it's going to be the S minus because it becomes SH. And as one of our students pointed out earlier today in a presentation, thiols do have a pKa a little less than 10. I told you to learn 10, but typically they're a little lower. And here's how much lower. Cysteine. Cysteine thiols 8. There you go. So when it picks up a proton, it goes to an 8 versus when this thing picks up a proton, it goes to something like 2. I don't need to look at the table. All of the ammonia, the carboxylates go to carboxylic acids pKa between 2 and 3. I'm going to go, the one goes to 8 because the pKb is better here. 16 minus 8 is 16? 14 minus 8. Don't know what happened there. 14 minus 8 is 6. 14 minus 2 is 12. I don't like a 12 base. I like a 6 base. All right, and it's going to go towards a pKa of 8. We just looked it up. There's your question mark. So in this scenario, you're going from 7.9 to 8. And negative 0.1. That's by far our best equilibrium, and KEQ is going to be equal to 10 to the positive 0.1. All right? And that will be closest to 0. That's not close to 1,000, trust me. Even if it was 10 to the 1, it's not close to 1,000. This is a tenth of 1. So there you go. And you got to remember what happened. You went to RSH. So you got rid of 2 answers here, right? The SKs are gone. Both answers that had SK in them for the next question are gone. You're down to this and this. Oh, there's only one SH. I'm done. That was nice. And that kind of summarizes everything right there. There's your 2 products. Okay? And that's the equilibrium that would go most to the right. And that's our segment there. And we'll see you with questions, I think, 4 and 5 on the next segment. And bye-bye.